Crystal Flow provides a rich set of review, visualization, and documentation tools. It creates professional-grade flowcharts from source code to help you understand and review the code in less time. It provides advanced visualization tools such as Enrich Trees, call flow, and data flow. It generates full HTML documentation containing flowcharts of all functions, call trees, caller trees, source listings, etc. It also generates software metrics including McCabe's, Halstead's, and volume metrics. Crystal Revs has all the capabilities of Crystal Flow, but in addition, it provides static checking, editing, and auto-formatting. These unique tools will help you complete your tasks in significantly less time. Let us see a few highlights of Crystal Flow and Crystal Revs. You can browse at the project level, file level, and function level. As an example, the Function Properties card will help you view and navigate to caller functions and called functions. You can create many types of trees, and you can browse and perform many operations on those trees. Here, we see the result of searching for JS decompile code in the call tree of main. You can display the call sequence from main up to JS decompile code. A call sequence is very helpful in understanding and reviewing code. This is the file call tree. It shows the call hierarchy of functions within a given source file. Flowcharts are easy to understand and easy to remember. The condensed view of the flowchart gives you a feel of the whole function. You can quickly walk through the flowchart by maximizing the detailed flowchart window. A comment flowchart can be understood by a wide audience. With a click, you can view the type information of all the variables used in a flowchart symbol. To understand a long function, first review the top-level flowchart of the function and then review the flowcharts of the major blocks of the function. In this way, you can divide and conquer very long functions in just a few minutes. In Enrich Trees, each node contains additional information to help you browse and understand code easily. In this tree, we can see the file names where each function is defined. Here, each node shows the list of parameters needed by the function. Here, each node shows the comment that is associated with the function call. The Enrich tree displays the members of the structure JS context that are used by the functions. It shows that the function JS atomized string uses the member runtime. The function JS alloc gc thing uses two members newborn and runtime. With a click, you can go to the data flow of these structure members. Now, we will take a look at call flow. Here, we see the flowchart of regex compile. This flowchart is very helpful in understanding the whole function. Sometimes, instead of the full details, you need to make a fast attack by viewing the flow of function calls. Here, we see the call flow of the same function. In call flow, the function calls are displayed in detail, and the rest of the statements are shown as miniature symbols. When you click on a miniature symbol, you can see the corresponding code highlighted in the file window. With a double click, you can expand a function call to go deeper in the call flow. By expanding the function call, we can now see the call flow of JS value to string. With call flow, you can make a fast attack and review many functions in many files in a short amount of time. This is the data flow of a global variable JS escape map. The initial view of the data flow tells us that JS escape map is used in 3 functions. Let us double-click on parse atom to expand it. We can see that in parse atom, JS escape map is used in one statement as an argument in a function call. To appreciate the power of data flow, let us take a look at the full flowchart of parse atom. Parse atom is a 300-line function. Instead of having to browse through this long function, you can use data flow to zero in on the exact statement and to view the control flow leading up to that statement. Now we are back to the data flow. Let us double-click on the function call to expand it. The expansion shows that after JS escape map is passed as an argument, the corresponding parameter is called s, and now the data flow is tracking the parameter s. The ability to track data, even when the parameter has a different name, will save you a lot of time. Crystal Revs provides static checking for compliance with MISRA C. You can catch rule violations early in the development cycle, contributing to better software quality as well as reduced software development and maintenance costs. Crystal Revs performs code formatting to improve readability. Crystal Revs does more than just indenting and line wrapping. For example, it lines up successive assignments. Above, we see the code before formatting. Because the assignments are not lined up, they are harder to read, and it may be difficult to detect errors in the code. Below, we see the code after formatting. Now, the code is easy to read and remember. You can generate full HTML documentation containing an overview of all files, functions, and data definitions. The documentation includes flowcharts of all functions. It includes call trees, caller trees, class trees, include trees, source code listing, cross-reference, etc. The HTML documentation can be viewed by anyone with a web browser without requiring Crystal Flow or Crystal Revs. The HTML documentation provides code metrics too. These include Halstead's complexity metrics, as well as McCabe's complexity metrics, volume metrics, etc. By using the Crystal tools, you can complete your tasks in less time. Instead of taking our word for it, download the evaluation version and try it for yourself.